Ever felt stuck because your Python code runs so slowly when handling a large dataset? Or maybe you have seen mind-blowing AI projects but you have no idea how to start working with big data yourself. If you have been wondering how tools like ChatGPT processes languages, how self-driving cars read camera images, or how companies analyze millions of transactions in a second, NumPy can process massive data up to 50x faster than regular Python lists. Almost every machine learning framework, from TensorFlow to PyTorch, relies on NumPy. Libraries like OpenCV use NumPy array to store and manipulate image data. Pandas, SciPy, Matplotlib all built on top of NumPy and the array structure. Whether in finance, healthcare, robotics, or gaming, NumPy is the common language of data. By the end of this playlist, you will go from zero to confidently working with NumPy arrays, functions, and real-world AI examples. So stop saying NumPy and start doing NumPy. If you find this video is helpful, like and subscribe to this channel. Let's start by installing Python. So simply go on Google, write Python download. Click on this first link of website python.org. Just choose your computer. It may be use operating system of Windows or Mac or Linux. For me it is Windows. Scroll a little bit and choose your type of Windows. So for me it's 64-bit, and it automatically download as you see. Then let's go and install Anaconda. Just search on Google Anaconda download. Choose this website of anaconda.org with a green circle icon. Just click on this link. Then scroll a little bit. Simply you can accept or reject these cookies. Then you don't need to fill all of this. Just click on download Anaconda. Then here you need to submit your email only, and just click on this submit button. Scroll a little bit. Then you choose your operating system. For me is Windows. Then I click on this link, and then automatically it start being downloaded. Now we can start Python. Just click on run. If it is your first time to start Python, you will click next. For me, already Python is installed on my laptop. So you can repair, you can modify. It's up to you. So let me cancel this, and then I come to install Anaconda. Then I can click next, and then I install. Wait a small moment, then click next. We may launch this. It come up with Jupyter Notebook and different tools you will see like Spider. Then click on start menu. You may search Anaconda Navigator. Just click here. Then wait a little bit. This will open the menu of Anaconda Navigator. Then scroll a little bit to Jupyter Notebook. Then click on launch. It will automatically open your browser, your default browser, and you can scroll. You can create a new notebook, or For me, I have a notebook. Then I can click it and open automatically in my browser. Let's see Google Colab. Just go on Google and search Google Colab. Then click on this first link of Google Colab. Wait a small moment. If it is your first time to use Google Colab, you simply need to make a login with your Google email. Just click create a new notebook and you start type your codes. So this Google Colab come up with all pre-installed data science libraries. NumPy is a library working with array. NumPy stands for numerical Python. It's created in 2005 by Travis Olive. It is open source. You can find its code on this Git repository. So why NumPy? NumPy is 50x speed over Python lists, reset, etc. So which means it is faster than lists. So foundation of data science and the artificial intelligence libraries like pandas, scikit-learn, or TensorFlow, or PyTorch are built founded by NumPy, the random number generation. That is where I fell in love with NumPy. So there is memory efficient, which means to manage memory very well, etc. and so forth. Let's start working with NumPy. By import it, we simply use keyword for import, and then we write NumPy in the lowercase. We may check if our NumPy is installed in our laptop by simply use version attribute. So we write NumPy and we put dot operator. We put double underscore when then we write version. So then underscore and then we run. So now you see NumPy is installed in our laptop and its version is 2.1 and 0.3. Most developers import NumPy as NP. So this makes easy to work with NumPy because to write NumPy is somehow too long. So this is an alternative name that used to refer NumPy. So simply write so the import as NumPy, our library. Then we put as operator and then we add NP. So instead of using NumPy, we are going to use NP. So then we check the version. Now it's done. By the way, you may download these notes in the description. There is a link to download these notes for free. So let's create an array by using NumPy. An array object in NumPy is called n-dimensional array. Mostly they say ND array. That is abbreviation we are going to use in this tutorial. So to create an array, we use array function. So this is used to create an array. So we pass an argument. This argument can be the list, can be a tuple, or can be also an array. Let's see how we create an array. We simply start by import NumPy as NP. Then we make the object. So this is the n object, or we can call it ND array. Write NumPy, and then we add our function, which is array. So inside this array, we may pass a list, we may pass a tuple, we may pass also another array. Let's try to pass a list. Let's say 1, 2, 3, and 4. Now we may try to run this one. Now you see our array has been created very well. Now we may need to check the type of this array, or check a type of this object. So we simply use type function. Then we pass an object inside this parentheses. So object we are going to pass is this array. Then we simply run this, and you see the type of this object is NumPy ND array. Let's see the dimensions of arrays, or ND array, as we have looked in Python. So dimension is where the array changes its specification. So there is different types of dimensions in array. So let's look at one by one. First one, as you see, is the zero-dimensional array. So zero-dimensional array, So this is the array which made up by one element, or we can call it a scalar. So let's take a look by import NumPy as np. Now to create this array, let's call it, so let's call it 0d. Now this is the name of object as C. Then we can say np.array. So now this array is made up by only single element. Let's take for example like 1. So this is the example of 0D array or 0-dimensional array. So now we can check the dimension of this array by simply use attribute of ndim. So let's try to say print. Now we are going to print the array name. So our array is called array 0d. You see, then we use ndim attribute to see the result is 0, so which means our array is 0 dimension. Then the next one you can see is 1-dimensional array. This is the array which made up by the list of elements, or we can call it a vector. So that element should be arranged in one row and many columns, like table have one row and many columns, or table have many rows with one column. So let's get it. For example, we have an array which is 1D. Let's call it 1D array. So np.array. So now we may parse the elements like you see here on the screen. We may pass like element with one row and many columns. Let's take for example 1, 2, 3, 4, and 5. Now we may need to check the dimension of this array. I see. Let's run this. Now the dimension is 1. 2-dimensional array. So this is the array which made up by the element arranged in many rows and many columns of a table, just like matrix. So let's take the example of this matrix which have 2 rows. So we are going to simply write this matrix in Python statement. So we simply start as normal and we needed to create our object. Let's say this is an array with 2 dimensions. So let's call it 2D. Now we can put the np, then array as function to create the array. So we are going to start with that square brackets of blue. So this is, let's take this as blue square brackets and let's write that elements. So the next it is that green square brackets, and then we insert the elements. Then we followed by comma. Each element is separated with the comma. You get it here in the example. This is the 1-dimensional array element separated by the comma. This is on the second. So second D array, each element is for 1D array. This you can say is like a set. So this set, its element is made up by 1D array. So 1D array is the element of 2D array. So now here we can continue. Then you simply write 3 and 4. So we can take it like a set. So we are 1D array elements. So 1D array are the elements of the 2D array. So now we can check the dimension of this array. We simply change here by 2. Then we run this. So you see this the second dimension array. On this 3-dimensional array, so we are going to make it as well on 2D array. So the simple secret is that 3D we can take it as the set that hold all elements of 2-dimensional array, which means so 2-dimensional elements separated by comma are make up the 3D array. So let's take this example. Just like say let's select this. So let's create 3-dimensional array. Let's say array or of 3D to understand this very well. So now to make it clear, we need to set matrix made up with another matrices. So as you see on the screen, let's write this matrix in a statement of Python. So we start from this red square bracket. Let's write this is the red square bracket. So to write the remaining matrix, as you see, the matrix for 2D is the matrix made up this 3D. So it becomes more matrix. So this matrices, so we simply select this matrix for 2D and just paste it here, and you separate it with the comma. So this comma separate the elements of 3D. So now we can also paste this is the second element here. Now we can paste it again. This is the third element. So this is just like matrix hold different matrices. So now we can run this and we check the dimension of this 3D array. Then shift it press A. Now you see this is 3D array. So that is it about dimensions or in the array. So that is the great job. If you allow me, I can teach you how to access each element in each dimension from 0 to dimension of number 3. Let's see how to access element in the array by using NumPy. Let's start firstly by importing NumPy here. You know, I like to be fast. That's why I prepared some code. Let's start by creating an array by using NumPy. We simply write np, then we use function array to create an array. Now we created an array, so we can check the dimension of this array by simply writing that array. This is array 1, and then we use ndim attribute to check a dimension. Now you see this dimension of array is 1. To access the element or any element in this array of first dimension, we write array name and we put index inside this square brackets. As you see on this picture, each element it has its position, or we can call it index. First element start from 0 and the other followings. So to access example of this 3, we mean we are going to write the name of array. This is array 1. Then we put square brackets. Inside the square bracket, we are going to pass an index of that value. Now we need to access this value 3. Let's write, so this value 3, as you see in picture, it has index 2. Now I have to print this object. To print it very well, let's use print function to print it very well. Now we can run this. Now you see we access element 3. You can pause the video and you try this one. If you found the answer, write it down in comment. Let's see on dimension of 2. Now I prepared this array to reduce time, and then we can check the dimension of this array. This is 2. Of course, we can write the array name as we done above, and we write the ndim. Now the dimension is already 2. An array in 2 dimension, we take it as a table. If you don't know about this, you can watch this video. Just watch this image. An array, we take it as a matrix or n table. To write these elements in a way of matrix, we can make this in editor. Then we click on backspace. Again, also this. And now it looks like that one we have in this image. Each row start from 0 and each column start from 0, as you see in this image. If we need, for example, to access the element number 7, we are going to use this syntax. We write the array name and we add in square bracket row and column. To access this element number 7, let's do in Python. Now we write the array name. This is array 2. We put square brackets. Then we write the row of this element 7. So this element 7 is on row 1. Now we write 1. Then we put comma. And this 7 is on column 2. Now we can write 2, and then we try to print this on screen. If I press enter, now you see the result is 7. If we want to access 0, now 0 is on row 2 and also is in column 3. Then let's run this. Now you see the result is 0. You can pause video and you try this. You choose the right answer and write it down in the comment. Now on 3 dimension, you can check the dimension of this array. Now simply we write array. So this is array. We can call it array 3. Let's call it array 3. Then name. Then we learn. This is 3-dimension array. To understand this, how to access this element of 3-dimensional array, let me sprite it as how I have done on 2-dimensional array. I'm going to press enter here. Then again, I'm going to press enter. This is the array made up with 2 elements. Now this element also I can break down it. So this we can take it as a block. Let's call it block 1. Now I can take another block. So this is block 0. I'm sorry, we call it block 0 to make it clear, as every time we start by 0 in array indexing. Now this we can take it as block 2. Now to access an element in 3D, we use blocks and rows and columns. Now this you can take it as a whole as block 0. Now this you can take it as row 1. Let's go to row 0. Yes. Now this is row 1. And we will take it as it is on the second block. Now to access the element, we use this syntax. We write array name. Let's call it array 3. Write array name and we take it first as block and second as row and then another one as column. As you see, now to access this is simply easy. Then column start from 0 and row start from 0, as we have seen in the 2-dimensional array. This we can take it as 2-dimensional array, this from green square brackets, and we add also this block. It's simply what added in this 3-dimensional array. Then we simply, to access this, we write array name. Then we write square brackets. The block, let's say example, we are going to access this 10. We are on block 0. Then we write 0. Block 0 on row 1. Then we write 1, as here you see. On row 1, 10 is on row 1. Then is on column, we have column 0 here and column 1. On column 1. Then I may run this. Now you see it is 10. To make it a beautiful output, let's write print function. Now you see the result is 10. Okay, you can try this question. I'm going to pin the first comment, which is correct. Forget loops and if conditions in NumPy. You can manipulate and extract the data with just a few powerful slices. In Python, you can access and reshape your data in just 3 lines. No loop, no hassle. And don't miss the end. I will show you how slicing is used in real life with pandas to manipulate the data in just 3 lines. Let's get started. Before we start slicing in NumPy array, let's get this master key. As we know, we access array by using square brackets and pass index. And this is a NumPy syntax for slicing. It follows the same standard of Python list slicing. So this is the syntax. This is X is example of an array name. Then we pass start and we add also stop and step. This start is where our slice is going to start from. stop is where our slice is going to end to. Yes. But what I need to point is this: if there is any value that are not specified by default between these three values, start, stop, and step, if there is one not specified by default, it assigns start to 0 and stop to size of that array with its dimension, and step it is by default set to 1. That is the master key that is going to help us understand well slicing in Python as a way of selecting a part of an array or sub array. Let's continue in coding. Let's start by importing NumPy as normal. Then we run this cell. Then we continue to this one, the array cell. We are going to make slice for one dimensional array. This is the syntax we have seen in the previous moment. And then this is the array made up with the list of 5 elements. First element is index 0, second element is index 1. Now this is our syntax we have seen. We can start by selecting first 3 elements. Just to write array name and we put square brackets. For first space, we write an index. We are going to start from selecting the part of an array. Let's start from index 0. We are going to start from 10. Now we can put this colon and we put it where we need to stop by selecting elements in an array. Let's stop from the number which have index 2, because 3, even we write 3 is not in the result. We will start from 0 up to 2 index. 3 will not included. Now we can put a colon again and we will write our step. It's just like incrementation, and we try to run this. You see, now it's select from index 0 up to index 2. 3 is not in the result. If I try to change here and I write 2, you wanna see the result is 2 elements. You start from 0 and the 1 index. Don't get a problem about this output. Even you are seeing array, it is just because I didn't print this. I didn't print this by using function print in the Python. That's why it is displaying that. If I use this print function, it will display this. Let's make here from leave nothing and we run to see what we have seen in master key if it's working. When you unspecified the value, what happened? Now let's run this. You see, it's the same. Here automatically is set to 0. Now we can try when I delete these two, what will happen? We will select all element, which means here it's just like setting to 0, and on this value, because it is not specified for stop, it will reset to size of dimension. Let's learn this. Now you see it is select all elements. It's just like setting to 0, and here we set an array size. To set an array size, this size an array have 5 elements. Now to check an array elements, you can use length function. Now you pass your array. When I run, you see the array has 5 elements. Okay, let's make this one comment, and then we back here. What if I put 2 on step, which means it will just like select one element and skip another one. As you see, it selected 10 and skip one element to 30, skip one element to 50. When I try to put negative on here step, let's put negative here, and you see it's just like making reverse. So now we start from 50 and we skip one element because we step by 2, and we check another. It's just like making reverse, as you see on this picture. Now I can change here from step 2 to 1 to make it very easier. I run this, you see we start from 50. This is just like changing an index of this element. What can happen when nothing was specified here? Or element as set. We have seen when we left here nothing, what compiler set in the master key. Now it just run all of array as this. Let's go on 2-dimensional array. Here I prepared the array of two-dimensional array. And then let's make slice to this array. We use this syntax as normal. We write array name, row, and the column. Let's try to select a part of this array. We write array name, and we put a row here, and here we will add the column. On row, we can make slice, and we say we are going to start from 0 and up to 2. We are going to select 2 rows, and on column we may start from 0 also and up to 2. Let me explain this virtually. And on this step we just say we are going to select from 0 up to 2, which means it is row 0 and row 1. This is what we are going to select for this first technique. And while on the column, we are going to say, even if we have selected the 2 rows on column, we are going to select column 0 and column 1. Then we are going to select this column 0 and column 1. That's why you see the output is 1, 2, 5, and 6. This you are saying here, row 0, row 1, row 2. This is the index 1, 2, 3. This is the column or index of this array. Let's go on three-dimensional array. If you have already seen the previous video about the array indexing, this three-dimension is going to be like just drinking water. Then I prepared this syntax. We first write block, row, and column. We just need to write in this technique for slicing. I prepared here the simple statement to make it easier. Let me move this indent. And then let's first run this, and we see this is the output. Let me explain all of this very well. Let me sprite this output to make it easy analyzing. Now first we are going to select a block. This is from 0 up to block 1. You have seen on 1D array, we say if there is value not specified, it's set to 0. Now we select here block 0. Now this is our block 0, which means we are going to select the block 0, no block 1 included in the result, because we will select 0 only, 1 does not included. Then on row we are going to select from 0 up to 1, which means we are going to select these rows. In block 0 we are going to select these rows, as you see. And what about on column here? And column will start from 0 up to 1. And also in column we are going to select from 0 up to 1. The column, this is vertical, from 0 up to 1. This is here. You can draw it like this. Now this intersection cell, we can say this is the output. That y is 1, 2, 1, and the 10. Let's see how we can apply these skills of slicing by manipulating data by using pandas. Let's start by importing pandas as PD. I will explain this in the next tutorial. Then we need to create data frame by using pd.read.csv. Now we are going to import data. This is data is CSV, which means common separated values. This value are separated by comma. Make sure this data file or CSV file is the same, is in the same directory with your notebook, and you write pd and you are dot. Then we use method called the read CSV. Inside this parenthesis, we are going to pass that the name of our file. Then we put its extension. Now already data has been imported. Now I can try to display this on screen by simply write this. If I run, you will see now it displays this CSV file data. It's made up by 169 rows and 4 columns. Now I can select one of these columns, like a part of this CSV file, just by writing this square bracket as we have done in the NumPy, and then we write first. We start from 0. Now we need to select simply like 10 rows, and if I run, you will see I select first the rows of this CSV file, and then I can change, and I start from like 2. If I run, you see I start from second up to 9. Arange function is used to create one-dimensional array to specify the value. How we do this? I first import NumPy. Then I use np.arange function. Now I can pass a value. Then if I run this, it will create an array from 0 up to 11, which means I create an array of 12 elements. Now we can rename our array to an array like this. Reshaping function is using to change a shape of an array. We simply write an array name and we write reshape function. Inside the reshape function, we pass a particular argument. It depends on what shape of array you want. Let's make this array of 2 dimensions. We need to pass first a row. Now let's make array of 4 rows and 3 columns. Make sure when you product this, it will give you 12. And then let's run this. It will create an array of 2 dimensions with 4 rows and 3 columns. And also we can convert this into 3-dimensional array by using also reshape. How we do this? You should know about 3-dimensional array. You remember in the previous video how we explained 3-dimensional array. First we pass a block. Let's say we need to make an array of 2 blocks. And then we are going to pass a row. So each block will contain the element have 3 rows. Let's write 3. To make sure we fulfill with these elements we have in 1D array, we should multiply these 2 elements. Now we have 6. The remaining value is 2. 6 times 2 is 12. If you write this, we may run. Now you see it gives an array of 3 dimensions. So we may rename this array as new array. Now let's print it again. You see it's the same. Let's say we try to change here and we write, for example, 3. This will give error because I told you a secret is to multiply these elements or arguments, and we check if the value is equal to elements number of that array. Now let's return to 2. We may need to convert it back into 1-dimensional array. That is called flattening an array. We use a reshape function again. Then let's use reshape function. Inside the reshape function, we need to pass a -1. This will convert back to 1-dimensional array. Let's run this. You see, it converts back. Iterating an array is going through elements one by one. Let's create an array by using Arange function. Let's create array of 12 elements. How can display this? Now we created an array of 12 elements. Okay, we may access that element in this array one by one by using row. Let's use for row. We simply write for, and we can write element in our array. Then let print each element by simply write element. If I run this, you see, we access element one by one. We may do this also on two-dimensional array. We are not going to create a new array. We simply use this one. But to make it two-dimensional array, we use the function reshape. Let's create a new array from our first array was array. That we are going to reshape it into two-dimensional array of 3 rows and 4 columns. Now I can print this, and now you will see it is two-dimensional array of 3 rows and 4 columns. We can access these 3 elements by using group. We simply write for, then we make element. We may say x, for example, x in a new array. Now let's print x. This will display x element down. This is 3 elements of two-dimensional array. Now we access element one by one. But here, there is still small confusion. Even is we accessing 3 elements of this two-dimensional array, but this return element arranged in also in a list. To handle this and we access each element as alone, we simply use nested loop. Here we will need to add another loop. So write use for, and we may define this loop as y in x, because x also is just an array. Then here we can also print this element. Let's print y. Let's remove this indent. Now we can run this. This will access each element as alone. We can also do it as well on 3 dimensions. Create 3-dimensional array. We need to use reshape again of this array. Try to do it faster. Let's say it is array 3, which is going to be equal to our array, and then we use reshape function. So reshape function, going to pass a block. Now let's say this 3, and here it is 2. Now if I try to print this, you will see it is an array of 3 dimensions. To access these 2 elements of 3-dimensional array, we use loop. Let's say, for example, x in an array. Now we may print this x. Now you see, we are accessing it as 2 elements. To handle this, you see, we will remove first this square bracket. Remove this square bracket, we use row. Let's add the next row. Let's say this is y and also x. Now this is where we are going to print our value. Let's print y. If I run this, there is still a square brackets. To remove this again, we need to add another loop. We use for, let's say w in y. Now We may remove this statement. And then we print W. If I run this, see we are accessing element one by one. A simple secret to access each element as alone, or I can say a number, you need to use a loop. In fact, if you are in 3 dimension, you use 3 loops. If you are in 2 dimension, you use 2 loops. If you are in 1 dimension, we use 1 loop. If you are in 4 dimension, you use 4 loop. If you are in n dimension, you use n loop. Joining NumPy array is putting 2 or more array in single array. To do this, we use concatenate function. I prepared these 2 arrays to help you understand this concept. Write concatenate these 2 arrays. We write NP, stand for pandas, and we write concatenate function. Inside these 2 parentheses, I'm going to pass that array I needed to concatenate or to join. And when I run this, you see our array has joined. Also, we may spliting NumPy array. This act is reversing operation of joining. Joining merges multiple arrays into one, while when we spliting, we breaks one array into multiple array. To do this in Python, we use array split function. Let's first name this joined array. And then we are going to split this joined array into 3 arrays. We use NP and we use function array split. For first argument, we pass our array. Then our array is joined array. While the second argument is the number of array you want from that array you are going to split. Let's say we need 3 array. Then let's run this. Now you see, we created 3 arrays. We may need to sort an array on any sequence order. To do this, we use sort function. We simply come here and write NP and write sort function. Inside this sort function, we need to pass our array we need to sort. Then if I run this, you see our array is sorted. Whether you need to search a certain value in an array, you can use where function. This where function, it returns the index of that value you want. And also in where function, you can pass a condition. Let's take a look. To search an element, we may say np dot where function. Now here we can search in this array, we write array name, and we search the element which is equal to 40. Now this will return the index of where 40 is located. How many value of 40 we have is 1. Let's run this. Now this element is located on index 3. If you count very well, you can find 40 is located on index 3. You can also pass the condition inside this function of where. By passing a condition, you can write like a condition that calculates or find the number that is divisible by 2. We simply use modulus sign and we take the remainder from taking each element in an array, we divide by 2. and we found if the remainder is equal to 0, we will return the index where that element is stored in the array. Let's run this. Now you see, this index is for number that divisible by 2 or even number. Arithmetic operation may be done in two ways in NumPy array. Let's start by using method of operator. We may add these two functions by simply use a normal operator, which is addition. And if you run this, you see 10 is added to 20. Each element add with another element in another array for the same index. Now we can perform this action by using add function. By simply write np stand for NumPy, and we use add function to add these two elements. But we remove this operator plus and we add comma. If I also run this, it will return the same result. And also you can do it for subtraction. We may use subtraction function. If I try to run this, it will take 10 minus 2, which is 8. I can also multiply these two arrays by using multiply function. By simply write multiply function, and then I pass these two arrays. And then if I run this, you will see each element multiply with other element in the second array for the same index. And also you may use divide function. Let's try this. Oh, sorry, I made the mistake here. Let's divide. And I run this. So each element was divided with its corresponding element on the same index. Why do you actually need to run a random module in NumPy? Random are used in game development, like when you want to choose a random enemies or loot drops. It's also used in data science, random sampling. You can use the random module to generate a dataset. That dataset you can use it to train and test your model. It can also be used in simulation, like Monte Carlo experiments. Security, like encryption keys or password generation. What about random number? Random number are totally different with different numbers. Random number that cannot be predicted, and a random number can be repeated, while different number cannot be repeated. Let's see pseudo-random and true random. Pseudo-random are that values generated by the computer programs. They can be repeatable if you know the formula that you use to create that program. While true random, these are naturally random values, and they are different. NumPy library have different models: polynomial, cohort testing, random, or Fourier models. But today I want to point on random model. Random models have different methods as listed here, like CD, permutation, shuffle, up to uniform. Let's start by random n. Let's go on VS Code to test one of these methods. Then already we reach in VS Code, we need to import random module. Now we can say from NumPy, we need only random module. Now I can say, for example, I have a die, then I needed to choose random side on that die. How to do this? I can simply just print the any side I will choose. Then simply I can use random module. Then I can use rand int function to generate the integer side. Then I need to start from 1 up to 6. That is enough. It can be 7 because 6 will not include it. Now if I try to run this, now the first time I will get 4. If I run it again, then I get 4. If I run it again, then I get 2. If I run it again, I get 1. This is a random generation of the integer value by using method randInt. Again, I may want to choose in the collection. How I can do this by using random. I may also say print. Then I'm gonna to choose between tail and head on the coin. Then you can say coin will be. Now I can use my random model, and then I use choice function. Inside the choice function, I can pass the list or any collection you want. Then I can say this is head, and also I can pass a tail. If I try to run this, the first time it is head. Again it is head. If I run again it is head. If I run again it is tail. This is random choice. You might need to generate the array of float values by simply write print statement, and inside here you can pass random with the method randN. This is going to create a single value of float. If I run this, it generates this value. But if I pass 10, it generates 10 values. This is the array of 10 value. What if I pass 100? It generates 100 values. I can't live without showing you a normal distribution where you can create a data, and that data you transform into dataset. That dataset you can use it to train and test your model. Most popular is normal distribution. This normal distribution fits the probability distribution of most events like IQ score, heartbeats, and others. To access this, you simply apply this syntax. We write NumPy, and you add the random model and the normal function. We need to pass log parameter, which is mean. Scale is a standard deviation, and the size is the shape of the array. Let's go faster in VS Code to test this distribution. Okay, we have already imported random model. What simply we are going to do is to write random, and we select the normal method. Inside the normal method, we can pass the size of 100 value. If I run this, it creates an array of 100 values. To make it better distribution as we want, we define that 3 arguments. The first argument is log, which is equal to mean. Let's say the mean is 1. Now I can pass the standard deviation here by simply write scale. Then I make scale equal to 2. If I run again, it creates the distribution we want. That is it about random model. If you want to make more, you can go on browser and you search NumPy documentation, and you learn more about random model.